Hello everyone. Welcome to Lecture 7, Clustering with R. This is a hands-on lecture about how to do clustering with R. The dataset that we are going to use is the irises dataset. The algorithms that we are going to use are the affinity propagation clustering, the affinity propagation with k-means clustering, and the affinity propagation hierarchical clustering. This package or affinity propagation clustering comes from bioinformatics, and if you go to the website you are going to find more information about the algorithms, and you're going to find many papers and up-to-date information on affinity propagation clustering. And if you look at it, it came from the Institute of Bioinformatics. The user manual is available here. If you look at it, this is the user manual is right now is loading. This is it is 45 pages. Some of it is easy reading, but it is worth browsing through. Also the reference manual, which is harder to read, which is more of for a programmer, is also available on the same website. It's also another 41 pages. Also, if you issue the command vignette AP cluster from R without these external codes, but this is like if you issue vignette from AP vignette AP cluster from inside R Studio, you are going to get the PDF for the user manual. That being said, this is the web page, and this is the user manual, and this is the reference manual or the programmer manual. And this is if you issue the command vignette, it will launch the PDF for it. But before that, you have to load the data set. Anyway, just a reminder, to be able to do clustering, we need a data set. We also need to be able to calculate similarity matrices or distance matrices. We need to be able to run some clustering algorithms. We need to analyze the results, and we need to iterate back until we are comfortable with our results. Basically, we are doing exploratory data analysis and descriptive data analysis in the process. Now, just a reminder, some of the distance measured from the lecture 6 are the Euclideans, the Minkowski, the Manhattan distance, etc. And these are some of the measures that you can use for your clustering. The data set we are going to use is the IRIS data set. It is for linear discriminant models. It was created in 1936 by Ronald Fisher. He wanted to perform discriminant data analysis on some data set, and the data set was created by Anderson. Sometimes it's called the Fisher-Anderson data set. The whole idea is they have three types of irises: the setosas, the versicolors, the virginicas, and they want to do the sampling and the data analysis. If you read about here, all the species all came from the same pasture, picked on the same day, measured almost at the same time by the same person with the same instrument. The four features are the sepal length, sepal width, petal length, petal width. I forgot which one. The sepal is, I think, the outside, the petal is on the inside, or the other way around. You can check Wikipedia for that. Now, if you look at the data set, how do we load data iris? Will load the data set, and then we view the iris data set. If I find my R Studio, if I say data iris, it will load the data set. Now if I double click on it, I will view the data set. This is, you can see there is 150 records. If I say summary, iris, I will get summary statistics, the sepal length, the min, the max, the first quartile, second quartile, the median, the mean, the median, and the third quartile. And for the species, telling me since it is categorical or nominal, there is 50 of each. This is the data set that we are going to use. This is more of descriptive statistics on the data set. I use ggplot here to plot the data set. You can see that, for example, if I pick this one, the petal width in here, you can see that they are low here, medium here, and this is the setosa, the versicolor, and the irises. Yeah, sorry. Like if you look at this data set in here, we are plotting the petal width versus the petal length. The petal width is on the y-axis, the petal length is on the x-axis. If you look at the setosas, they are on the low end of it. The versicolor are in the middle range, and the virginica are on the high end of it. It means that if the petal length is high and the petal width is high, it's most likely it's going to be a virginica. If you take here, we also have a clear separation. Here we have a clear separation. What does this say? We are plotting the petal length versus the sepal width in here. If you look at it, if the petal length is very low and the sepal width is high, it's most likely it's going to be a setosa. If the petal length is medium and the petal width is the low to medium, it's most likely it's going to be a versicolor. The same thing here. If the petal length is on the high end and the petal width is medium, it's most likely it's going to be a virginica. And these are the density plots for each one of them. And here, this is the density plot for petal length. It looks like it is bimodal, and the density plot for petal width, and it looks like it is a bimodal plot too. Now let me plot this one and this one to show you what do I mean by the bimodal and things like that. If you run this code step by step, if you run this code, the first one is going to this is the, let me zoom out so that you can see it. This is the plot of the sepal length by itself. It is crunched because I wanted my range to be between 0 and 1.5. What I mean by that, if I did not have the y limit, you're going to see bigger. You're going to see it bigger, but then I will lose the other data. The other data will not show up. Anyway, if you run this code, then you add the lines. This is for the setosa, and the red one for the setosa, the green one is for the versicolor, and the fourth one is virginica, and the fourth is for the versicolor. Probably I got them flipped in here. You are going to notice a couple of things. The red ones are for the setosas. I got mine flipped in here because here this is versicolor color 3. Here I'm saying virginica color 3. We should flip these. Control C, Control V, Control X, Control V. You should be able to fix this. Now they do match. The setosa color 2, the versicolor color 3, the virginica is color 4. Probably the labels here are so they have some errors in them. Okay. If you notice that the reason we have it becomes like this, because if you add all of these together, it will become this way. Now for the second one, if when we plotted the petal the petal length, it was bimodal. It is bimodal if you plot it in here and pay attention to the y limit, it being this and this. Now if I plot the setosas by themselves, it is the red one. If I plot the virginicas, the same thing. It looks like I messed up these things here. I will let you fix it. It looks like should be versicolor, and this one should be versicolor, and this one should be virginica. This one should be this one should be versicolor, and this one should be virginica. Now if you plot them, you notice that we have two modes. This one is separated from the other two modes. Anyway, this gives you an idea on how we analyze the data, especially when we are doing exploratory data analysis, and we are plotting graphs. The same thing, if you plotted the petal width in here, you are going to find also a bimodal. And from the diagram in here, for example, we know this is the petal length, it's on the x-axis. We know this is the sepal length, it's on the y-axis. You can think of each one of these as an xy plot. For example, this one here is the petal width on the y-axis and the sepal width on the x-axis. This is kind of the first part here. The next part, I'm going to start with how do we create clusters.